you. And thank you, Dibs, for giving me this opportunity to talk about green infrastructure and stormwater management in general. It's just something I've been very passionate about for the life of my career, both here and abroad in my many practices. So ideally what I want to try to do today, I know you guys have heard about green infrastructure. I am going to go over just sort of the basic premise of green infrastructure, the different types, and the benefits of each one, and then how you take all those items and really kind of apply it to a project, site specific, client specific, regional specific, just so that you can get the best fit. Because what we find a lot is it's great that these guidelines are being put out, city, state, that they're trying to develop green infrastructure practices, but it's never one size fits all. The minute you start doing that, we're going to do this throughout the city, it's just not the same. Communities change, as you can even see within Hoboken. You walk this River Street, it develops as it goes between the campus. There's a park, things like that. So you got to find things that really can fit into that site-specific area so that it is a benefit. Because the worst thing that can happen is you put in a green infrastructure element and it fails, because then the community loses faith, the client doesn't want to deal with it. So it's very, very important to be sort of transparent up front with what the capabilities are and how they can function in a certain site. So real quick, green infrastructure. What I like to say mainly is that it's a decentralized system, because I think that's key. For years and years, especially urban areas, just created a central piping system. Everything was captured, taken away real quickly from impervious areas and discharged, whether to a treatment plant if it was a combined system, or outflow into the water. So it's really a way to kind of just mimic what naturally was there before the development happened, and how do we create that in an urban environment. Reason it's key is urban development is growing dramatically. The predictions right now are that 80% of the population is going to live in an urban setting by 2050. So with all that increase in population comes the increase in impervious area. And with the increase in impervious area creates less infiltration, less deep infiltration, less runoff, or more runoff, and less evaporation. So you got to kind of counteract that. And for so long, urban environments were just building, adding new piping systems, sort of standard systems, and not addressing the overall environmental impact of just hardscape, and the sediments and pollutants that would be captured and discharged. So, like I was saying, there's a lot of different impacts that this creates. The growth in urban population is great in some respects because it can rely on similar systems with transportation and the infrastructure in general, the utilities and things like that. But if they're not treated properly and the growth just continues to happen, we constantly have issues with increase in rainfall events, increase in heat index and things like that. So we got to find ways that we can counteract all of those elements. And green infrastructure is just one part of this. I could talk about all the others for a long period of time, but it's just one of those things where it's just, you got to start tackling it one by one. And green infrastructure is a really great way to do that. So I like to break green infrastructure down into 4 categories. And before I continue, if you want to ask me a question, tell me to slow down, go back to something, please feel free to interject. Because like I said, this is a topic I'm rather passionate about, so I get going. But please feel free to interrupt me and ask any questions. So like I said, we sort of break it down into 4 categories with green infrastructure. And these are important because this is going to impact what you can choose for certain areas that you're designing in. Or looking to construct in and things like that. So sync it.
What theory you meant to the theoretical and practical? Like any mechanics involved in here?
Yeah, so technically what is the green infrastructure element capable of? So you can look at something and say, all right, and I'll get into this a little bit. If I'm going to have a bioswale, I know that I need to be this off the water level, I need this much of space, I need this much of infiltration sand. Like there's the design in the theoretical state. There's the other part of it when you actually implement that bioswale in a parking lot where you're not you didn't do an infiltration test, and you're not totally sure, but you're going to scoop out that the soil that's there, just put in good infiltration sand. What's going to happen to that over time? How is it going to function? And I'm going to get into some examples from projects where we've had some successes and some unsuccessful and had to go back to the drawing board and reevaluate. So I'm going to kind of go through the theoretical, the technical textbook elements, and then I'm going to go into some project-based, what has worked, what has not worked, and other elements I think you need to incorporate when you're designing as far as working with a client and working with the community. So sink it is just how it sounds. Basically, you want to hold the water, slowly infiltrate into the ground, create recharge. And there's a bunch of different options that you can do that. Obviously, this is very reliant on the soil type. You want a good soil that infiltrates properly, so that this can be a benefit to the project. There's slow it down, which again, we like to break things down into very simple terms. Slow it down, obviously, just you want to be able to hold onto the water, dissipate it a little bit, and then slowly release it back into the storm system and or the outfall system. So again, you want to try to decrease the peak discharge that happened with the rainfall event and with the increase in impervious area, and just slow it down and then eventually gradually release it back into the system. And those are some obviously options that allow you to do that. Reuse, water harvesting, land conservation, obviously restoring areas that were previously warehouses, landfill sites and things like that, and reusing them as a green space. And then obviously rainwater harvesting, whether it's from rooftops, from drainage fields and things like that. How do you reuse that? And what are some of the benefits of doing that? And then lastly, move it. Basically taking the rainfall, their water, and directing it sort of downstream to an area of storage. This here is a very well-known project in Yonkers where they actually, the Salmo River creek was covered over in the city. They eventually took a very large chunk of money to open it up and create a lot of storage and actually open up the whole area and really create this nice feature through the town, which actually has had great benefits. So I want to touch on just some of the benefits individually, because not all the green infrastructure elements carry all these benefits, but most of them touch on them in one way or another. And it's important to kind of walk through these with the client, because they're probably going to have something in mind that they're really looking to fix with their project. So it's really good to be able to walk through the benefits and what they can achieve, especially if they're not familiar with any sort of green infrastructure, if they're used to a standard closed system. So delayed stormwater runoff, obviously this has helped, like I was just saying, with all the construction, discharge rates go up. You're increasing the impervious area, the peak goes further up. So how do we actually delay the runoff a little bit? And that's what we were talking about when we slow it down. So here's just a hydrograph showing the difference between when you get the rainfall, when it hits a conventional roof versus when it hits the green roof. The green roof itself is going to slow down the process so that the rainfall will slowly discharge, almost similar to if it was still a pervious space. Next is reducing the stormwater runoff volumes. And here's just 4 different examples of projects we worked on and what you would get from 1 inch of a 1 inch rainstorm over an acre, and the actual runoff volumes that you would get from each one of these different services. So obviously, if you can reduce the amount of hardscape, you are drastically reducing the amount of volume runoff that you're going to need to either be able to treat or channel to some sort of flow system. Enhanced groundwater recharge. Obviously, this is really key because the majority of a rural population actually relies on groundwater for their drinking water, unlike an urban area that gets it from a system. So keeping groundwater recharge a constant element in your infiltration process is really key to the overall hydrological cycle. And these, again, obviously are the elements that would, sink it and infiltrate down into the groundwater. Pollution reduction. Obviously, it's really key to reduce the particulates that actually end up in the runoff. Because over time, obviously, that all ends up into the water, the open water system. So creating soft engineering elements like the plants, trees, things like that, that actually have the natural capacity to break down hydrogen dioxide, all these elements that end up in the flow system from hardscapes, parking lots, rooftops, things like that, creates a natural pollutant removal that is actually obviously benefit to the overall discharge. Another benefit is carbon sequestration. Obviously, this mainly comes a lot from trees, planting trees, which everyone has really gotten on board with. I'm sure most of you are familiar with New York City's program. And many other cities have done similar things because of all the recent studies about green space and the carbon sequestration that you can get from trees. A tree itself can remove emissions basically from a city street almost up to 60%. Obviously, the more mature a tree, the more sequestration you're going to get. So that is become a key element in green infrastructure and how you can incorporate these. A lot of cities and states have adopted a tree development program and benefiting the overall stormwater management as well. Again, I'm sure this is no surprise to anyone, but heat island mitigation. Obviously, hardscape creates a heat island effect. Our cities are getting warmer. It's an absolute certainty. And with just little bits of break, again, like I was talking about, breaking up a collective system of hardscape with a green roof, with green strips in between parking lots, with trees, you can reduce the actual temperature by a great deal. And, you know, as you see, you can trees can reduce air temperature up to 25 degrees cooler, depending on the canopy and things like that. So it's become a crucial element in green infrastructure as far as what you're planting, how you're planting it, and where you're planting it. Air quality is another element of mainly of trees and how they can lower the overall temperature and improve the air quality. Just a breakdown of cities and elements and how the trees that have been planted in these areas and like the canopy provided, obviously, how it has created the pollution removal. So it's just a nice number. And then obviously with more pollution removal also becomes a dollar sign, which is always a benefit to many of your clients. Future clients. And then overall improved health. There are a number of studies that have happened over the last 20 years, which have really shown that green infrastructure and just open space in general has a really positive impact on human health. Everything from socialization to safety to overall just kind of, you know, healthy and kind of activity has all been surrounded with green spaces and green infrastructure and the benefits that you can really receive from those. And then lastly, increased land value. Now this, as from an environmental point of view, it's kind of an interesting thing to look at, but it is crucial for clients for them to understand the benefit of what they're developing and the added benefit other than, hey, we're going to deal with stormwater management, but also because of how this can increase neighborhood development, other elements just in and around a community. Over here on the left, you'll see I have two pictures of the High Line in New York City. Rents within, and you can even see the development that has happened, rents within and along the High Line have actually increased by 50% since the High Line went into place. It obviously also had a great tourist attraction element, which the city has benefited from quite a bit. So it's one of those kind of caveats where it's good for a client to understand that there are added benefits outside of just the environmental stormwater management element.
Is the top picture, is that on the west side?
Yeah, so this was the elevated train rail that that got completely redone into a city park.
Because it was deserted.
Yes. So yeah, I mean, it was deserted for a number of decades.
Yeah.
And it was, you know, kind of an unsafe area to be and things like that. And a lot of people got together and created the Highline Committee, really worked hard to make it. And now it is, as you can see, a huge element of the city. I mean, pretty much if somebody comes to visit, I tell them to go walk the Highline because it's a beautiful walk. Yeah. So it really has transformed the neighborhood. You can take that any way you want, but it is an element of people like green spaces and they want to live next to them. They want to have, you know, the capability to take advantage of them. So after all that, how do you really incorporate this into a project? Which is the key element I want to really talk about. So what I like to do is sort of usually create a matrices of all the different options that are available to a client based on their site, and talk about what benefits they can get from those. You know, whether it be the recharge, the reduction, in addition to what most likely a city or state or federal agency will require. I usually like to push them a little bit further so that they understand that there are like some of those added benefits that I just talked about. So usually what I'll do is lay one of these out, just kind of show what is available to them, and then I like to sort of drill down a little deeper because maintenance, space requirements, now you got to talk about what actually is feasible for them to input into their project. I guess lastly, I would just say about this was just obviously for one specific project that had certain requirements, but some of these I knew right away I was going to like cross right off the list once I talked to the client, but I wanted them to see the full scope of what was an option in their area, what could work. And why it could work. But then I also wanted to peel back because we usually try to look at the maintenance. You know, I have a lot of city, state, and federal clients, so maintenance is always a huge issue, and I'll get into a couple of those project examples soon. But just, is it minimal? You know, is it going to be a lot of work? Are they going to have the right people that will know how to maintain it? Same thing with space. A lot of times, a client, if I say we're gonna have to lose some parking spaces here because we need to be able to fit the fire retention, they don't want to hear that right away. So then we have to go sort of through a cost benefit analysis for them to understand why you need that space because of the system itself. So I'd like to kind of put this all out, you know, pretty pictures and what benefits they'll get, and then kind of do a cost benefit analysis so they can really understand what they're getting with their choice. So get into some specific projects. This is a Coast Guard facility designed down in Texas. It was a design build project, which is always a challenge. Everyone's familiar with what a design build is? No. Okay. So a design build is a project where a client hired a design team to basically design a project about 75%, like take the design drawings, get them pretty close so that it's a biddable set, so that a contractor could come along and say, all right, I can build this for X amount of dollars. Then the contractor actually hires a design firm to be his designer of record. So you basically take those documents and finish them, and you know, you're signing and sealing and all that kind of stuff. So it becomes your design, but the contractor bid on the concept. So he has in mind what he's willing to pay. It's a way that you can sort of fast track a project. And it's a lot of times when the client was, it's the Coast Guard, they had lost their facility completely during a storm. They'd been kind of working out of trailers and things like that. They really wanted to get the system up and running. You can obviously we've elevated because this is right on the water, very susceptible to storms. So it is all hurricane rated. But it was a way for them to kind of get this done quicker than a normal design build process, which is where it would be designed 100%, signed and sealed. It would go out for an open bid. and then all the contractors would bid it, and the client would pick one. So we're working directly for the contractor rather than the owner in this case. And the reason I describe all that is because the original engineers and architects on this project had designed several underground sand filters as a filtration system for the stormwater management. When we got on board, they had done no borings, no real topo survey or anything like that. Very flat site, right next to the water. And we realized, I had the contractor do a couple of infiltration tests so we could see what we were really dealing with, find out where the groundwater level was. We had told them we didn't think the filters were a good idea. We had suggested we needed to do something on the surface a little bit further away because the water level, the high tide water level was much higher than we were told in the report. But again, contractor kind of bid this all as one. So he went ahead, because technically the underground filters worked. It was very close though. I wasn't comfortable given the proximity to the water that it would actually work. But the contractor wanted to go forward and proceed as it was shown, and as he had already bid it because my design was a bit more expensive. 2 years later, we got a call from the Coast Guard that they were having some flooding on their property. So sort of pro bono, the contractor and myself went to the site, investigated, and we went back and did the surface sand filters because we could get them a little bit higher up from the groundwater. We had the right infiltration for those kind of systems, and we could really position them better around the site rather than trying with a flat site, rather than trying to get everything to go to these underground systems, because we really didn't have the proper head for the piping system for that. And usually trust your gut, but knowing the site and trusting with what is bare minimum meets the requirements versus what is actually a better fit for the requirements is always a key element when you're dealing with soil conditions. Because even on a site like this, you could take 6 different infiltration tests and get 6 different answers that aren't even in the same range, because a lot of times in these sandy conditions especially, you'll get a lot of different ranges. So you want to make sure you're almost using the worst case scenario so that you don't end up with problems with infiltration and things like that. Another element that I always think is key is understanding your site conditions. And when I say that, I mean really your rainfall. We had a client in New York City Transit actually that we worked with shortly after Superstorm Sandy. Obviously, everyone knows. I'm sure most of you are around the area. Well, maybe not you guys, but obviously devastated this area immensely. And there was a lot of reaction. Quickly, let's build a wall, let's do this, things like that. And New York City Transit was very nervous. Obviously, they have Coney Island Complex in Brooklyn is their largest rail yard. Every train goes in and out of there, whether it's for maintenance, for washing, things like that. It's over 100 acres. It's right next to Coney Island Creek. So they were very adamant about, we want you to protect us to a Category 3 hurricane plus 3 feet of freeboard. And we want, and then we have a nice bathtub. And then we want you guys to design a stormwater management system that will deal with a 100-year rainfall event. And we're like, are you sure you want that whole combination? And they were like, yes, that's what we want. We never want another Sandy to happen to us again. So we understood that, but we also knew the price tag that goes along with that. So they were talking about a 12-foot high wall around a 100-acre property with 8 different gates, which were floodgates. And then they were talking about putting in detention for 100-year rain to hold 100-year rainfall, in addition to pumps, because if there is a storm event happening at this time, we got to be able to pump it out. So we kept telling them that we didn't think that was the right strategy for the yard. And we were having trouble really connecting with and on having them understand that. So what we did is we started doing some research just so that they could see that you don't always couple these 2 events together. Because you have a storm event doesn't mean you're having a severe rainfall event. And we thought it was crucial that they understand that, because as you see on the bottom there, the last 10 storms that have happened in this area. On the left, you see when they happened, which is important to note, like the dates, and most of them have happened in the last 10, 15 years. But the storm site surge, when you're at 100-year, which obviously we were at Sandy with the 14-foot elevation, we got a half-inch of rainfall. So we kind of had to lay this out for them so they really saw, are we putting your money to the best use? The wall, the detention, underground detention, and we're talking about an active rail yard. So putting underground detention and pumps just to deal with 100-year rainfall. It became a space requirement that we just could not accommodate for them. But also, when you look at it practically, we're not saying that an event like that could never happen, but you got to rely on the data and understand that they're not always sort of in the same plane. So this really helped kind of drive it home that, I mean, if you look at, Sandy wasn't even a 1-year rainfall event. Now the storm surge, a different area, and those are two different it's apples and oranges. And we really wanted them to understand that so we could kind of find the best fit for them for their yard. We thought that they could do with, again, use some open swales to deal with the rainfall event, the detention that was needed around the perimeter, and a much smaller pump to deal with a 10-year storm. And that would really cover them much better than just going 100 and 100 with a rainfall and storm. And eventually, we were able to convince them that that was the best fit. It's actually under construction right now. That's another thing. The other thing I always say, and this is the rail yard, is visualization for a client is key. They all experienced Sandy. They don't want another Sandy. We understood that. But at the same time, we wanted them to understand that, rainfall and hydrology in itself is always going to be sort of a crazy beast. And just look at your topography and where you really need to focus your energy as far as stormwater management, pump systems, and the protection. So we thought it was a really good idea if we could lay this out, because obviously, especially with transit, the key right there for them as far as what ponding they can deal with would be where the third rail is. Everything needs to stay under that. So we could develop a bunch of iterations with our HydroCrab program so that we could show them where they were really vulnerable. They knew it, but to see it out like this, because they were talking about stations and things like that were flooded, but they weren't flooded from the creek. And that's what we were really protecting them from in this project. So it really helped to kind of visualize. The minute we put this up, everyone in the room understood, and everyone knew where we needed to focus the money of the project and things like that. So we could start really getting into the design.
In that picture, the turquoise was flooded?
Yes. This is all 100-year. The red is where we're getting into critical higher elevations where we're really impacting the facility. But I mean, the other reason we want to show them this, like these are their facilities here. And they got floods in there, but it was because when they had got a system, drainage system that was undersized for the yard, over 100 years old, and we cleaned it out for them at the beginning of the project. And they were like, we had geysers in the facility. And I'm like, I don't understand how that happened. When we cleaned it out, there was concrete in the pipe. They had redone the floors in one of the buildings, and somebody just said, swept it right into the drains. It hardened. So I should have brought the pictures of those. This is in Coney Island Yard. Yeah, so this is their motor traction shop. It's like, but they were saying it was coming up through the pipes. We got surcharged, and I was like, I've done the counts. That doesn't make sense. And then when we cleaned it out, we saw, there were traffic signs in these pipes. Everything. We cleaned it out. I got a call from a head up at transit. Was like, it's actually functioning properly. I was like, yeah, well, you had concrete in your pipe. Like, nothing was flowing out of there. So again, all those parts helped us, really work with them and kind of create a solution that actually dealt with the condition they have. So that's another thing. Always know what you're dealing with when you're walking into a project, because understanding how that system worked. And again, that was something we were, right away, it was like, we want infiltration tests and we want to understand how this existing closed system is functioning, so that we can actually really fix the problem. Another key one, and I had to zoom this in so no one knows where it is understanding the community. A lot of times, like I was mentioning, a city will be, we want to push green infrastructure and we really want to make it happen. And the next thing you know is you get a standard design in a neighborhood that doesn't have the resources to really maintain it. And a city that is this big that can't maintain it, that relies on certain neighborhoods can. They have, we will do and things like that actually help clean up a neighborhood or a block or two. But when it isn't maintained and you know that resource isn't there, then this just becomes something where the community is like, well, it didn't work. We didn't want it in the first place. And now you don't always have control over that, but I think it is important to note that there are other options. It doesn't have to just be a one size fits all. So here, this bioswale was put into this neighborhood. There was no means of maintaining it. It became full of garbage. It became an eyesore. And by the way, it didn't solve any of the drainage problems. The street still floods. So I think reaching out to communities, I've gone to so many community meetings and tried to understand, even if they don't even know the project's coming, I want to go to those community meetings and listen to what they're saying about what the real problems are. I mean, since Sandy, I think I've gone to every board in the 5 boroughs, because that'll help me be informed with, when I talk to the client, listen, I understand that this is what you want on this street, but I was walking the street, I was talking to some people at the community board meeting, and I think this is a better fit. Might not listen to you, but I think it just is sort of a due diligence on your part to really make sure that what you're designing or what you're recommending is a good fit for that community. And there always are many options. So even some trees here would have been a more benefit. You can do those with the permeable pavers, and we could have stripped this whole street with a couple different tree plant pits that worked with a closed system. And then you would have still gotten a water quality element, which would have been a benefit. Space requirements, I talked about this. Again, this is where I think the cost benefit analysis is always key for a client if they're thinking about, especially, so this is a bioswale that we designed for a commercial space down in Baltimore. And commercial space, parking. They want the parking. They don't want anyone to not shop at their store because there's not enough parking. But we really needed a wide swath for the bioswale so that we could properly handle all the flow. And so what we did with this, we showed them the bioswale would reduce the need for an underground water quality system. That was a state requirement. The maintenance for cleaning out a closed drainage system versus the maintenance for the bioswale, and just kind of walked them through that the cost of losing 8 parking spaces wasn't a cause for concern at all, based on the cost that they were saving from using a natural filtration system. This has an under-drain system and one little clean out, so they just have to back truck it out once a year. And some minor, this is all natural to the area landscaping, so the maintenance of the landscaping itself is very low. We got rid of all the grass, so no mowing. It was all just natural vegetation, so it was really minor as far as how it needed to be maintained. So again, always just kind of walking through those benefits to a client, because I think a lot of times throw in a closed system, throw in an underground structure, but the underground structures, I guess I should mention that underground structures, water quality structures are like media filters. So it's just sort of a large vault that has a turbine to clean it. But again, it requires a lot of maintenance because it is an underground structure versus a natural system like this, which really just does the filtration through the soil system. So maintenance, I mentioned that this was a key thing I wanted to talk about, because I do think this is the contributing factor to why green infrastructure can fail. This was a bioswale we put in with an underground detention system. So it was twofold. We were taking care of our water quality and quantity, but a facility in the Bronx. This facility was pretty bare. It's about a 60-acre campus that was the client completely redesigned. It's a healthcare facility. And they built 5 new structures, So we did the entire site infrastructure for this, and the stormwater management obviously was a big part of it because it was a redevelopment, but there was still obviously a lot of increase in impervious area. So we put in all new utilities, stormwater management, a lot of pervious pavers and things like that. So this was all done. It looked beautiful. The underground is photoshopped in, of course. And about a year into it, we got a call from the client saying, we're having erosion everywhere. Soil's draining. We're having horrible problems on our plaza. And I was like, how is that possible? We went up there, and the gentleman who does the landscaping had only ever mowed lawn out there. Like, there was no real, he thought they were weeds, pulled them all out, and we had some runoff problems. So I was like, what happened? I have this beautiful picture where it looks so nice, and then, you know, we got to the bottom of it, and the guy's like, well, they look like weeds to me. And I was like, he's like, I've been mowing the grass here for 25 years, and I didn't know what to do. And I was like, okay, communicating with your client and the end user. And so now we actually write in landscape requirements into our specifications so that we can avoid issues like this. And we make sure that we can meet with the groundspeople, whoever they're willing to meet with us. You know, this is twofold in a building now, with green roofs, with water harvesting, you know, dual pipe systems for gray water. It's so key that this is communicated to the end user, who is actually going to try to maintain the system when they have been programmed to do something the same way for so many years, especially with, you know, a state facility like this. So it's become a thing where, you know, with everyone, we learn a little bit more, and we are able to include into our specs, write maintenance requirements, so that we make sure that hopefully we're leaving everything better, in a better condition, and that everyone understands really what is needed. So lastly, I just wanted to show you guys a couple projects that we've been working on recently. Don't mind the tires. This was, we worked on universal PreK in the city, where the city decided that PreK was needed for all. So they started looking at properties that they could quickly renovate to create these PreK spaces. And a lot of times we always wanted to make sure that they had the play space available, but that we could, you know, address the stormwater management within the site and not have to deal with a discharge to DEP. So here, the entire site is lined with trees and permeable pavers. We have small filtration systems underneath the pervious pavers so that everything from that playground site would drain. And then we're also getting the benefit of the trees for the children, obviously, within an urban environment. This is another healthcare facility that's in construction in the Bronx. This is an interesting site because it is right next to the water on the boardwalk in Staten Island, and was devastated by Sandy as well. So they really wanted to look at options that were natural to prevent the facility and the site from future storm issues. So what we did is we really recreated the grading throughout the site so that we could actually create these natural berms and natural infiltration basins. So there's actually 6 of them around the site. We put green roofs on the lower roofs. All the paving is permeable. So this site is completely self-sufficient from a stormwater management. There's no connection to the city DEP. And it's great. It's actually in construction. It's about to be done and should be open within the next 2 months. The last one I wanted to show you was the prep school. The Army Corps decided that they wanted to move their prep school from New Jersey up to their main campus at West Point several years ago. And this was an old landfill, which is always a nice challenge. So this housed everything. This was the barracks, this was the school, this was their recreational space as well, because they wanted to have their own campus separate from the college. So what we had to do here, and you can see in the forefront, we actually had to relocate a stream. And what we did was daylight this stream and make it larger so that it actually could handle more of the runoff and the detention from this site. Like I said, the football field, which unfortunately you can't really see in this picture, which is off in the bottom, that was over the landfill. So we had to make sure that all the stormwater management, even though that was a cleared landfill, and we did the deep dynamic compaction to make sure that all the settlement was out, We had to make sure that all the runoff and all the stormwater elements were a decent distance away, so we didn't have any long-term, just in case environmental issues, even though it was a cleared landfill. So what we did for that was all open swales on the exterior roadways that discharged into the stream. And then we had a small amphitheater that had filter strips in between it and the back to catch the runoff from the run. So everything kind of formed around the building. And again, completely sustainable. There's no connection to a closed system, which is always, I think, a key element to having successful stormwater management with green infrastructure practices. So that's my bit. Any questions?